All right, now that we've introduced the trigonometric ratios, we can go ahead and see them in action a little bit more with problems 12 and 13. So in questions in 12, it says find the missing sides for the triangle shown to the right, then check your answer using the Pythagorean theorem. What is the measure of the angle at B? Okay, so let's first address the side lengths here, the sides A and B, and I've just copied the triangle over here for our reference. So if I want to say find the length A first, right? Well, much like what we saw in the last video, A is the opposite side of this triangle, and I can relate that to the known hypotenuse of 20. So I'm going to do that opposite hypotenuse, that's the sine. So I could say that the sine of 35 degrees, that's going to give us the ratio of A, the opposite, divided by 20, the hypotenuse. Okay, so I'll go ahead and multiply both sides by 20. And that's going to give me that A is equal to 20 times the sine of 35 degrees. Okay, so I'm going to go ahead and just use my calculator to do that, and I'm going to get about 11.472. And I just use Desmos there, but again, you can use your own calculator at home or Desmos, whichever you prefer. Okay, nice, right? So that's A, and then for B, well, B now is the side adjacent to the angle, and I can again relate that to the known hypotenuse of 20. So that's going to be adjacent hypotenuse, that's cosine of 35 degrees. This would be then B divided by 20. So very similarly, we can again just multiply both sides by 20. And that's going to give us that B here is equal to 20 times the cosine of 35 degrees. Alright, and I'm going to again just use my calculator, and when I do that I get a value that's about 16.383. Okay, great. So that is the second side there. Now we're asked to check our answer using the Pythagorean theorem. So this is also pretty similar to what we saw in the last video. So for the check here, if we did everything right, then we should have what? We should have the sum of the squares of these two legs, A and B, to come out to be the same thing as the square of the hypotenuse, right? So we should have 11.472 squared plus 16.383 squared. Does this come out to equal the square of the hypotenuse, right? 20 squared. Well, that's a little bit messy. Again, I'll just bring up the calculator to help us here and get rid of these. And so we're punching in, oh sorry, make a little space there. We're looking at 11.472 squared plus 16.383 squared. And oh, well, like we saw in the last video, right, I'm not getting exactly 400, which is the 20 squared I see on the right side, but it's pretty darn close, right? And the reason why is because, well, we're approximating the values for A and B themselves, right? So I'll go ahead and record that. This is 400-ish, right? 400.00, and what was that? 9473. So 9473. Yeah, it's not exactly 400, but that's to be expected. Really darn close. All right, great. The last thing then we're asked to do is find the angle measure at B, and this is just a nice review of something else about triangles. For any triangle, the sum of all the three angles has to come out to be 180 degrees, right? So this is 35 degrees, this is 90 degrees, so how much is left over? Well, 35 plus 90 plus what is 180? 55 would be the angle there. So here I'm going to draw a little angle symbol. The angle at B here then would have to be 55 degrees. Okay, great. So that's going to do it for question 12. Let's now go ahead and look at problem, let's see here. I want problem 13 next, and here I'm going to get rid of this in a second. It says you're standing 100 feet from the Eiffel Tower and see a bird land on the top of the tower. You have really good eyesight. If the angle of elevation from you to the top of the tower is 84.6 degrees, how tall is the tower? Okay, so here is the picture off to the right, and want to go ahead and find the height here, right? How tall is this tower? Okay, so I'll come back over here and get rid of that. We want this figure here, sorry about that, and this is not problem 3, it's problem 13. Mislabeled that there. Alright, so let's go ahead and set this up. Now we have this angle here, 84.6 degrees, and this is y, and that's 100. Okay, so this is the opposite and this is the adjacent. So opposite, adjacent, oh, that's tangent. Okay, so we can solve this by saying that the tangent of the angle, that's 84.6 degrees, that's going to come out to be the same thing as the ratio of the opposite side of the angle, that would be y, divided by the adjacent side of the angle, and that'd be 100. Alright, great, and so then I'm going to go to multiply both sides by 100 to solve for y. So these divide out, and now I'm left with y is equal to 100 times the tangent of 84.6 degrees. And then again, I'll just go ahead and use the calculator there and see what we come up with. So we got here 100 times the tangent of 84.6, and that is 1057 point, and I'll just round it, say to 0.9. Okay, so 1057.9, and the units there would be feet because the distances are all given in feet. So that would do it, and actually that is pretty spot on with the true height of the Eiffel Tower, by the way. If you go ahead and look that up, maybe off by a couple feet. But all right, great, that'll do it.